Okay. All right. Thank you. Now look at that last class. We have seen that's this two, right, so far. And then we know that how this one operates, right? So when we apply a zero, no, when we apply positive voltage in the gate of this NMOS, and this is NMOS, and this is a PMOS. So when you apply a positive voltage at the gate, this one on, and this one off. Okay? Now we can summarize here the gate voltage, and this is NMOS and PMOS. Get আমরা VZ লিখে রাখি, VZ is a gate voltage. Gate voltage, NMOS and PMOS. Right? Now, if the gate voltage is a positive, then NMOS on, PMOS off. And if the gate voltage is negative, or we can say zero, right? Negative or zero, যদি বলি logic, then right? If we put a negative voltage here, so there will be no channel here. No channel means no current flow. So that means this one will be off, and the PMOS, we already know that when you apply a negative voltage here, then then there will be channel here, and the current will flow. That means this one is on. So this is the summary, right? So based on that, and this is a gate voltage, and gate voltage only, and the gate voltage is the main one, is a dominating factor. So if we know that, then what we can do here, let's say if we connect one PMOS, let's say here we take one PMOS here, and one NMOS, we take one NMOS here. So we know this is a drain, and this is a drain, this is a source for NMOS, and this is a source for PMOS, and this is a drain, and this is a gate. This one is also gate, right? So the two transistors, one this is a P, আমি শুধু P লিখি, and this is N, right? PMOS and NMOS, and are connected in almost connected in series, say side by side, and one is in the top and one is in the bottom. And we have to put this one bottom because the source for the NMOS is ground. Remember that we learned last class. The source for the NMOS is ground, so this one will be grounded source. And the source for the PMOS is high voltage. We already learned last class. The source for the PMOS is high voltage. That means in here we apply a positive voltage, and here positive voltage, we call it VDD. Okay? So okay, at this point এটা না দিই, এটা positive. Let's say it's a positive voltage here, and is a ground here, and now we connect these two drains. Right? Two drains are connected here. Two drains are short circuited, and we'll take the output from here. Let's say this is the output, or maybe put output, and what we do, we connect these two gate, because both are gates are connected, and we got a common input, common point, and we call this is a in. Right? So this is a circuit, and this is a kind of circuit, and now we see how does it operates, right? And we put it here, input input voltage and output, and we'll see how does it works. first we will apply some apply high voltage, right? The input is high, right? High voltage we apply here. Input is high. So when the input is high voltage, so then what will happen? When input high voltage, then go to the PMOS. This is a PMOS, and we know this. If we apply high voltage at the gate of the PMOS, then there will be nothing happen here. There will be no channel and no current flow. But in NMOS, we learned last class, if we apply a positive voltage here at the gate, then there will be a channel underneath this gate and the current will start to flow. So that means this one will be on. Right? This one will be on. Right? This one will be on in this time, and this one is off. PMOS is off, NMOS is on, and input is high. Right? Input is high. Input high, PMOS off, NMOS on, and then what happened to the output? If this one is off and this one is on, then what happened? The ground, you see, the ground will be connected from here to the output. The output will be connected to the ground, right? So then output will be
low.
Low means zero, right? Zero voltage. Ground is connected, 0 volt. 0 volt. Right? And the next time we'll put a negative voltage or low voltage here. Low voltage in this time. We'll put a low voltage here. We put a low voltage in the input, and here is a low voltage. If we put a low voltage, then the NMOS will be turned off. This one will be off, and this one will be on. Right? At a low voltage means negative voltage or 0 voltage, right? Then the PMOS will be on. When the PMOS is on, there will be channel here, and then this is a positive. We see the B positive will be short circuited with this one output. Output will be short circuited through the channel with the output, with the high voltage. But this one is off, so there is no way to be connected. So then the output voltage will be B plus. This high is high and will be B plus. And what about the voltage? So now if you look at this, look at the truth table, high, input high, output low, then input low, output high. Right? So what does it mean? What does it mean? So what is this gate then?
Not gate.
Not gate, yes. So we got not gate. Here, this is a not gate, and without doing anything, any other things, just a one PMOS and one NMOS. There's no resistance, no BJT, no capacitor, no inductor, just on by only two NMOS, one NMOS and one PMOS. That means one CMOS. We can consider that we can build one inverter just by using one CMOS. Right? One PMOS and one NMOS is considered as one CMOS. So by using one CMOS, we can build an inverter. So this is the most simplest circuit. And now, how do you do it in practical, in physically? This is a symbol, right? In here we are just connecting by symbol, but now physically, what do we do? The physically we do, we'll see that. Physically, we do like first we take a bigger pieces of because we have to make a whole CMOS in here. One substrate is a P-type substrate. P-type substrate, right? P-type, and inside the P-type, we have to make an N-type substrate. In a half or almost half of the area, we put an N-type. So what does it mean? Is N. So inside the P-type substrate, we inject N-type material, right? Phosphorus or what is called arsenic. We add phosphorus or arsenic here, so this whole area will be N type, and this area will still remain P type. And now, what we do in here, we make another those another N type area here is called N plus, N plus, and inside this N type we call is actually NOL. This is known as NOL. This is called substrate. This thing, the whole thing is called substrate P type, and this bigger, almost half of the area is diffused with N type material, and we call it NOL. And inside the NOL, we make 2P plus. In here is we apply boron in here and turns into P plus, is a P plus. Now this one is actually turns into a PMOS, and this one will be NMOS, right? And we have to make it as a one piece, right? Both. So now it will be, the whole thing will be CMOS, and on top of that, so now this will be the source drain for PMOS, source drain for NMOS. And now we need to make those gate area, and we know that the gate area will be here is silicon dioxide, and here also is the same thing. The gate are same, silicon dioxide, and on top of that, on top of the silicon dioxide, we need to apply, we need to add poly. Poly in here also, poly is a poly, so that means the gate. So the two gate, this is a gate, one gate. So this is the PMOS, right? Is a PMOS, and this one is NMOS. So now the whole thing is called CMOS. And now this is a one gate, and we make this two gate short circuit, and these two gates are short circuited, and that will be the actually the input point. That is actually in. That was the input, and now we have to find which one is source and which one drain. And we know that drain of the NMOS is negative, is grounding. So this will be the drain, no, this will be the source for the NMOS. So this is a source and grounded, and this one will be the drain. So this is a drain for the NMOS, and we know that the source for the PMOS is high voltage, and source will be high voltage. So now this one is a source. This one is a source for the PMOS, and that will be VDD. Actually VDD, and this one we call it actually VSS. We call S, and this is called VSS. And now, and this is a drain. This is another drain for the PMOS. This is a drain for the PMOS. This is a drain for the NMOS, and the two drain are connected, and this will be the output point. So this is the one CMOS, and we connect those two drain, we get the output, and to get we apply input, and this is a main power supply, and this is a ground, and so this whole thing is not gate, right? Whole thing is not gate, or you can say 7404, right? TTL 7404 করেছো তোমরা স্টাডি করেছো DLD 1 this is the same thing here, but still this is a side view, right? This is the side view, the cross sectional view. So if you want to see the top view is the real view, and that is actually inside the integrated circuit, right? And if you see how many pins are there, how many input and outputs are there, this is a VDD, and this is a ground, one input and one output, right? The 4-pin main power supply will be in this one, like a pin number 14, right, of your IC, and pin number 7 is grounded, and this one will be maybe pin number in one, pin number 1 and pin number 2, right? Inside the 7404, there are 6 inverters, 6 NOT gates are inside those 7404 IC. So, but these are common. This pin number 7, pin number, no, pin number 14 and pin number 7 are common for all those 6, right? এর ভিতরে 6টা ইনভার্টার আছে, 6টার জন্য এই দুটো দুটো করে পিন লাগবে, 1 2 3 4 5 6, right? And then 7 is here, and then 8 9 10 11 and 12 13, right? 6টা ইনভার্টার আছে আর 14 হলো VDD. So this 14 is common for all the inverters. We'll see that later on. We'll make the real circuits, and but anyway, so this is the very simple diagram for by using one CMOS we get one inverters. But this is, as I mentioned, this is a side view. Now look, consider if we want to see from the top, that is actually we need to draw, right? Our main job will be to draw the layout, and layout will be the top view. Now if you consider what will be the top view for this one, আমি নিচে একটু মুছে ফেলি, এখানে ড্র করতে চাই। দেখো তো টপ ভিউ কেমন করে দেখা যাবে। Top view, it will be looks like first whole thing will be there, right? Rectangular things will be there, right? It will be rectangular like the piece of straight, and inside the piece of straight, right? Let's say there is NOL, right? আবার একটু দেখাই, ছোট করে যদি ড্র করি, এটা NOL এর ভিতরে এটা P ছিল। So now first is a P substrate, right? This is a P type, P sub, and then inside the P sub তারপরে কি ছিল, এটা NOL ছিল। উপর থেকে যদি তুমি দেখো, you will see a hole, the big hole from here to here. তো আমরা দেখি এখানে, we will see a big hole like this. This is NOL, this one, right? This line, this thing will be seen shown from the top. So this is called NOL. And or ভিতরে কি দেখতে পাবে, what we can see inside the NOL, we will see from the top, you will see this a P, and this is a drain, and this is a source area, and the P type, you will see a P type area here, P plus, and another P plus in this side. Here, this P plus we'll see here from the top view, and this one will be seen here in the top view. And in here, what you can see from the top, you cannot see the silicon dioxide. We'll see only the poly, right? Silicon dioxide is here, but we will not be able to see that. We will be able to see only the poly from the top. So this is this side, right? This is a P type silicon. No, P type PMOS. This is a PMOS, right? And in this side, what you can see? We can see in here, we can see this N type. This is N type, N type. In here, we'll see here N type. And this one, the source, and this one drain. We also will be able to see here, in here, right? This N, this one here, N plus, and then in the middle, we'll see poly in here, right? We'll be able to, I'm going to black color day, and is a black. My red is not working, so we need to bring in the red. So, and now in here, same as silicon dioxide, we will not be able to see. We'll see only those poly. Right? So this is the diagram. This is the physical one. We will have to draw this. Right? This is the, and you have to, when we really fabricate it, that in your fabrication class maybe you are learning. So when we want to fabricate this one, or really we manufacturing this in this not gate, so we have to take this the big one, big substrate, and the white one. We consider the white board is the base, and then inside that we have to make NOL first. This NOL, and then inside this NOL we have to diffuse two boron area, add extra boron or extra holes, we make a P plus, and in here we add arsenic or phosphorus, we make it N plus, and then in the middle here and here we put a silicon dioxide, and then we'll put a polysilicon here and here, and that's all. Here is a PMOS, here is NMOS, and the whole thing is CMOS. Now we need to make connection, right? We need to make connection here, and on the only the connection is remaining. What are those connection? Let's we consider this is a source, right? This source will be connected with the ground, right? This is a ground. This is source will be grounded, or we call it BSS, and this is the source, right? We call it VDD, and what is that? And this is the drain. This is the drain. This two drain will be connected here, right? This will be the output, right? Output, and the gate. Where is the gate? The pulley is the gate. You see here, pulley is the gate. Okay, we can. Okay, we need to clean a little bit. Here, the gate is here, and here is the gate, right? And here is the gate. So now we're done. Now this is the input. Always gate is the input, and drain is the output. So this is the real diagram of integrated circuit of or 7404 NOT gate. But this one is still doesn't look so good, right? This one is still, you see, this one is living in here. If you look at that, this is a gate and this is another gate, but these two gate must be connected here. But this one looks a little bit far away from each other. So what we can do, we can bring this one instead of making this length, right? We can squeeze and bring this one on top of this one. So that one will be I'll draw and looks better. And we'll see here. This one will be looks better. Let's say we take this is a whole thing here, and we'll make a NOL here. Make NOL here, and we'll put a N type here, N type here, N plus and N plus, and make 2P plus here is a P plus and P plus. Oh, this is a P substrate, and this is called NOL. And now inside in here will be silicon dioxide, and then poly, and it's the same as here. It will be poly. So now this poly and this poly is close to each other, and now we can connect it here, connect it here. So this whole thing, right, will be poly. And now this is done. This is looks very nice, right? It's better than the previous one. And now we have to connect. Let's say this one. We consider this one is a source, right? One of those P plus will be source, and one of these N plus will be source, and the other one will be drain. So what we consider? Let's say this one we consider the source, so connected with the VDD, right? And here, and one of this one will be considered as a source for NMOS. This is NMOS, and we consider VSS. And this is a drain. Let's say this is a drain and this is a drain. So the two drain will be short circuited, and so this will be the output. This is out, and the input is here. Input is the gate. This is the input. So this is the real diagram. This one actually you will have to draw, right? This is the things we are going to learn for complicated circuit. and this is called layout, right? And by using software, it will be very nice and very multicolor diagrams. But this one is not so good, though. But yeah, when we draw by using your in your palette, the color palette, it will be very looks nice, because every material or every component has a different color. You cannot use the same color for multiple things. Right? Any question?
Sir, one question, sir. Yeah, sir, if we at first build a N substrate and then make a P well, is there happen any problem?
No, but naturally আমরা ওই নেচার থেকে যেটা পাই সেটা আসলে পি টাইপ পাই। তাহলে তোমাকে আগে এন টাইপ বানায় তারপরে আবার ওর ভিতরে পি টাইপ দিতে হবে। বুঝতে পেরেছো?
Yes, sir. Yes, sir.
নরমালি আমরা নেচার থেকে যেটা সিলিকন পাই ওটা পি টাইপ, মানে ক্লোজ টু পি টাইপ, মানে আমরা আমরা কি বলে তুমি এন টাইপ প্রথমেই যদি তুমি এন টাইপ তৈরি করো, দ্যাট ইজ ওকে। তোমরা যে কিসে তৈরি করেছো সলিড স্টেটে, তোমরা পি টাইপ এন টাইপ তৈরি করেছো না সিলিকন থেকে। তো তুমি যদি এটা
জি, স্যার।
হ্যাঁ এন টাইপ সাবস্ট্রেটটাই নাও, দ্যাটস ওকে, নো প্রবলেম। সো দ্যাট উইল বি অপোজিট। তাহলে তুমি এন টাইপ সাবস্ট্রেট নিলে তারপরে পি টাইপ ওয়েল তৈরি করলে, তাই না? দ্যাট ইজ নো প্রবলেম।
Okay, sir.
And any other question so far? আমরা এখন আরেকটু মোর কমপ্লিকেটেড সার্কিটে চলে যাব। এখন আমরা অ্যান্ড গেট তৈরি করব, কিন্তু এটা এই লেআউটটা এখনই করব না। আমরা আগে যেটা প্রথমে কি বলে সিম্বল দিয়ে করলাম, দ্যাট ইজ দিস ইজ কল্ড লেআউট ডায়াগ্রাম। হ্যাঁ, এটা তোমাদের মনে হয় এখন এই যে ফ্যাব্রিকেশন করাচ্ছে, ফ্যাব্রিকেশন ক্লাস হবে, তো ওখানে এটা লাগবে, এই জন্য আমি এটুকু একটু দেখিয়ে দিলাম। আর আদারওয়াইজ দরকার নাই। দিস ইজ লেআউট ডায়াগ্রাম। হ্যাঁ, কিন্তু আমরা লেআউট ডায়াগ্রাম ডিটেলস শিখবো আর একটু পরে। আমরা আগে ফার্স্টে সার্কিট ডায়াগ্রামগুলি, ওইটাকে বলি আমরা মস ডায়াগ্রাম, ওইটা আমরা আরো ডিটেলস শিখবো বড় কমপ্লিকেটেড সার্কিটের জন্য। রাইট? দেখো আমরা সোফার আমরা কি দেখেছি, তাহলে এখন আমরা খুব সিম্পল খুব কুইক আমরা ড্র করতে পারবো। So this is a inverter and this is y is equal to a bar, right? This is a আমাদের not gate, right? This is called CMOS diagram. এটাকে আমরা বলি CMOS diagram, right? And this is very important কারণ তোমাদের এইটা if you cannot draw the CMOS diagram, you cannot draw the layout. So if you do mistake here, you will be doing mistake in all the other parts of this course. And this is a very fundamental components. So there is no way you can do a mistake here. কারণ তোমাদের অনেক কিছু করতে হবে, এই যে লেআউট ডায়াগ্রাম, তারপরে ক্যালকুলেশন, টাইম ডায়াগ্রাম, কি বলে রেজিস্ট্যান্স, ক্যাপাসিট্যান্স, টাইম ডিলে, পাওয়ার ক্যালকুলেশন, সব ডিপেন্ড, এভরিথিং ডিপেন্ডস অন দ্য কারেক্ট CMOS diagram. তোমার যদি CMOS diagram wrong হয়, so everything will be wrong. দেখতে পাচ্ছ তোমরা, রাইট না?
জি স্যার।
আচ্ছা, আমার স্ক্রিনে এটা কি মিরর দেখাচ্ছে কেন? এটা 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 কি এরকমই সিস্টেম নাকি আমার কম্পিউটার স্ক্রিন? ওকে, দেন doesn't matter, I am not looking at the computer. Anyway, so now let's look at a little bit more complicated one. And then, okay, so this one is, let's say in here, this is a right Boolean equation for the AND NOT gate, y is equal to a bar, right? And in here the input is a and output is y, or you can write the other way also, right? you can put a y bar is equal to a, right? Both are same. So input is a and y bar. So this is not get. So that means in here there's only one input. One input. Output is doesn't matter. Output is always one, but input is one. So the number of CMOS. There are some basic rules. Let's say if a Boolean equation has the two inputs, has a Boolean equation has a two inputs, then we need two CMOS to design the IC. And if a Boolean equation has a five inputs, so you need a five CMOS to design the integrated circuits. But in here, we have only one input. That's why we need only one CMOS to design the circuit. One CMOS means one NMOS and one NMOS and one PMOS. But now we'll go to a complicated circuit. Let's say here y is equal to AB. What is the Boolean equation? This is for AND gate, right? And if you look at here, there is a two inputs, A and B. There are two inputs. So if it's a two input, then we need a two CMOS. Two CMOS means two NMOS and two PMOS. Right? We need a two NMOS and two PMOS. Right? And so far, we have learned some basic things. We have learned that every CMOS has a PMOS and NMOS. The PMOS, the source for the PMOS is positive, high voltage, and the source for the NMOS is negative, ground. That's why the PMOS always sitting in the upper portion, upper area, and NMOS always sitting in the lower area, right? PMOS in the upper area and NMOS in the lower area. Right? Because NMOS needs the source ground and PMOS needs the source voltage, high voltage. That is always in the top. So, but in here, when you have a two PMOS, in here is when y equal to AB, that means is an AND gate. So this AND gate needs two CMOS. Two CMOS means two PMOS and two NMOS. And we know that the PMOS will be always in the upper side and NMOS will be in the bottom side. So we can divide it into this whole thing into half and put it two PMOS here. Here is a two PMOS and one is another PMOS, and there will be two NMOS here, NMOS, and we put a two NMOS, right? Just আমরা randomly এখানে put করলাম যে we need a two PMOS and two NMOS. Right? Now the question is how? Because before, in case of inverter, we had only one NMOS and one PMOS are connected with series. But in this case, we have a two PMOS and two NMOS, and we cannot connect all in series because there are two of those. Right? There are a rule that if the PMOSes are connected in series, the NMOSes must be connected in parallel. Right? This is the rule for these VLSI circuits. PMOS গুলি যদি প্যারালালে কানেকশন হয়, NMOS গুলি সিরিজে হবে, অথবা PMOS গুলি অথবা NMOS গুলি যদি প্যারালাল হয়, PMOS গুলি সিরিজে হবে, right? একটা আরেকটার opposite, vice versa, right? So now we need to know which one will be connected in series or which one will be connected in. We can easily understand the other one. First, we need to find only one set. Let's say, but in here we have two PMOS and we have two NMOS, but we have to go with NMOS because NMOSs are the fundamental circuits, because inside the NMOS, the electrons are flowing, and electrons are very lightweight, and electrons are very high speed, right? And electrons are available in the ground with a free of cost, right? So that's why the fundamental device for these two, NMOS and PMOS, is actually the base device is NMOS. So now we have to consider the base device. how these NMOSes will be connected in case of AND gate. তোমরা বোধহয় পড়েছো। ও আমাদের কি টাইম কত? আমাদের 3টা বিষয় নাকি শেষ। তোমাদের ক্লাস আছে এরপরে?
জি স্যার, 3:30টায় ক্লাস।
3:30টায় কেন? ক্লাস তো 3টা বিষয় হওয়ার কথা।
না স্যার, 3:30টায়
কোন
3:30 পর্যন্ত ছিল।
কন্ট্রোল ক্লাস।
ও আচ্ছা, ওকে, ও টাইম চেঞ্জ করে নিয়েছে তো, আচ্ছা আচ্ছা, ওকে। তাহলে আর একটু দেখো, আমরা এই যে তোমরা এই যে সার্কিট 1 অথবা কোথাও ইলেকট্রন সার্কিট 1-এই হওয়ার কথা, তোমরা দুইটা এই যে সুইচ কানেক্ট করেছো না এরকম, একটা সুইচ আর একটা সুইচ, এই দুটো কানেক্ট করে তুমি একটা ল্যাম্প জ্বালাতে চাও, এটা তোমার পাওয়ার সাপ্লাই। তাহলে এটা অ্যান্ড গেট তৈরি করবে কি করে? এই দুটো সুইচ দিয়ে সিরিজে দেবে না প্যারালালে দেবে?
স্যার সিরিজে কানেক্ট করতে হবে স্যার।
সিরিজ, রাইট, গুড। সিরিজে দিলে অ্যান্ড হয়, রাইট। নাও দেখো, যখন অ্যান্ড হয় তখন বোথ মাস্ট বি টার্ন অন, রাইট। এটা দুটোই অন না করলে জ্বলবে না, রাইট। আর যদি তুমি ওয়ার গেট করো, দেন ইট উইল বি প্যারালাল, রাইট। ওয়ার গেটের সময় প্যারালাল, তাহলে অ্যান্ড গেটের সময় দুটো সিরিজে হয়। সো আমাদের সেটাই নিতে হবে। So that means আমাদের in here is an AND gate. So that means this 2 NMOS here must be connected in series. The connected series connect করব কিভাবে? আমরা যে কোনো একটা নিচে একটা উপরে দিতে হবে। So we can make a connection by using that. So আমরা এরকম করতে পারি, এটা কানেকশন দিয়ে। এটা নাও দেখো একটা সিরিজ, this one is up and this one is bottom. So these two are in series, right? These two are connected in series. যেটা বটমে থাকবে সেটা will be connected to the ground. This will be connected to the ground, is called voltage VSS. আর যেটা উপরে থাকবে that will go to the output. This is going to the output, right? These are connected. Now these two are connected in series. If these two are connected in series, তাহলে PMOS গুলি will be connected in parallel. এটা parallel connection করতে গেলে কি করতে হবে? In here. Now these two are in parallel. See? Now these two are in parallel. উপরের মাথা, top part will be connected with a high voltage, and the bottom part will go to the output. Now we'll connect to the output. That's done. Right? Almost. আর কি করতে হবে? আমাদেরকে এখন পেয়ার করতে হবে CMOS. আমরা বলেছিলাম একটা NMOS আর একটা PMOS মিলে একটা পেয়ার হয়, called CMOS. So now we need to consider which one should be a pair, which two should be one pair, right? And যেটা পেয়ার হবে তার গেট গুলি কানেকশন করতে হবে, right? Let's say in here, okay, আমি যদি এটা একটু নাইস করে ড্র করি, এটা দেখতে ভালো দেখাচ্ছে না, looks like a parallel but actually series, right? আমি যদি এটাকে একটু নাইস করে ড্র করি, এটাও একটু ঘুরাই ড্র করি, দেখো আমি এটাকে এই দিকে ড্র করি, this is a PMOS, right? These two are in parallel. এটাও আমি এভাবে ড্র করলাম, আর এটা now in series. You see, আমরা এটাও দুটা ঘুরাই ড্র করলাম, this is a VSS. দেখো এখন আমি দুটাকে ঘুরাই দিয়েছি, this একটা PMOS, এই দুটো two PMOSes and two NMOSes. And আমরা জানি, একটু আগে বলেছি, I already mentioned, যে one PMOS and one NMOS will make one pair and known as CMOS. And যখনই one CMOS হবে, then both gates must be connected, right? তাহলে আমরা কোনটা নিব? আমরা এই PMOS আর এই NMOS টাকে যদি আমরা একটা মিলাই একটা CMOS তৈরি করি, তাহলে ওইটার গেট will be connected here. আর তাহলে other remaining, this PMOS and this NMOS will be short circuit, gate will be short circuited, that will be other. So these two actually the input. Now this is the input A and B, and the output will be coming from where? To drain. You see, this is a drain, short circuit here, and this one also is connected in series. So this is the main drain. And also, if you look at that, this is the reference line. This is the reference line. The upper side is PMOS, and the downside is NMOS, and the connecting point is actually output. This is a Y. So this is the CMOS diagram for the AND gate, but actually not. Right? আমরা এটাকে AND gate বলেছি যদিও, কিন্তু আসলে এটা AND gate হয়নি, and আমরা AND gate তৈরি করেছি কিন্তু, রাইট? আমরা এটা নিয়েছি, এটা এই ইকুয়েশন নিয়ে এটা করেছি। কিন্তু এখন যদি আমরা একটা দেখি, ট্রুথ টেবিল তৈরি করি, যদি আমরা এ বি আর ওয়াই, রাইট, আমরা যদি 0 0, আমরা যদি ট্রুথ টেবিল তৈরি করি, 0 1 1 0 1 1 1, 0 মানে নেগেটিভ আর 1 মানে হাই, রাইট, লো হাই। তাহলে এখন যদি দেখো, বোথ যদি 0 0 দিই আমরা, if we put a 0, এটা হলো b, এটা হলো ইনপুটটা হলো b, a b দুটো আমরা যদি 0 0 দেই, দুটাই 0 0 দিলে কি হবে দেখো তো? দুটাই 0 দিলে এই দুটো PMOS অন হয়ে যায়, and these two NMOSes are off. এই দুটো NMOS যদি অফ হয়, তাহলে তো গ্রাউন্ডের সাথে নো কানেকশন উইথ দ্য আউটপুট। both are 0 0, that means both PMOSes are on. আমরা লাস্ট ক্লাসে শিখেছি যে 0 ভোল্টেজ বা নেগেটিভ ভোল্টেজ দিলে PMOS অন হয়, আর PMOS যদি এটা যদি অন হয়, তাহলে VDD will be short circuited with the output. So we'll see VDD here. আবার যদি নেক্সট ওয়ান A0 B1, তার মানে A0 এটা যদি দিই, তাহলে এটা অন, এটা অন, আর এটা অফ, আর B তে 1, B তে যদি আমরা 1 দেই, so this one on but this one off. Now if we look at the output, output is connected to the VDD through this transistor, but output is not connected to the ground because this one is on but this one is off, but they are connected in series, right? এটা সিরিজে থাকার জন্য এটা অন না, সেকেন্ড এটা অফ, রাইট? দে আর, এগুলি সব সুইচের মতো কাজ করবে, রাইট? আমরা জানি যে ট্রানজিস্টরস আর জাস্ট লাইক এ সুইচ। তাহলে এখানে আমরা, তাহলে গ্রাউন্ডের সাথে কানেকশন নাই, but output is connected to the VDD, so in here will be VDD again. And the next one 1 0, এটাকে যদি 1 দাও, এটা 0 দাও, তাহলে এটা হয়ে যাবে অফ, এটা হবে অন, আর এটা হয়ে যাবে অন, এটা হবে অফ। এগেইন দেখো, তোমার আউটপুট উইল বি VDD, এটা অন আছে এর ভিতর দিয়ে, এটা VDD হবে। শুধুমাত্র 1 1 যখন দেবে, তো এই দুটো অন হবে, অন অন, আর এই দুটাই অফ হয়ে যাবে। উপরে PMOS দুটো অফ আর NMOS দুটো অন হলে গ্রাউন্ডের সাথে আউটপুট কানেক্ট হয়ে যাবে, তখন হবে 0। Now if you consider this truth table, this truth table is not for the AND gate. This truth table is for NAND gate. So that means আসলে আমরা এইটা তৈরি করতে চেয়েছিলাম, বাট হয়েছে আসলে এটা y is equal to AB বার হয়েছে, রাইট? এবং এটা কি গুড না ব্যাড?
So bad.
No, this is good. কারণ তুমি জানো না NAND গেট তো ইউনিভার্সাল গেট না? সরি, দাঁড়াও একটু, অনেক একটু পরে টেলিফোন করে, অনেক মানে ক্লাসে আছে 5 মিনিট পরে। ওকে ওকে, এনিওয়ে, তো তুমি তাহলে তোমরা পড়েছো না NAND গেট আর NOR গেট হলো ইউনিভার্সাল গেট?
জি স্যার।
তাহলে তুমি 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 দেখো, তুমি AND গেট থেকে যদি NAND গেট বানাও, তাহলে কি করতে হয় তোমার? আর একটা ইনভার্টার লাগাতে হয় না?
জি স্যার।
হ্যাঁ, তাহলে একটা ইনভার্টার লাগাইয়ে তোমাকে ইউনিভার্সাল গেট তৈরি করতে হতো, আর এখানে দেখো এমনিতেই এটা ইউনিভার্সাল গেট তৈরি হয়েছে, রাইট? সো দিস ইজ গুড, রাইট? and this is the good for all kinds of this MOS diagram, right? এই MOS সার্কিটে, CMOS ডায়াগ্রামে তুমি যত তৈরি করবে, যত সার্কিট আমরা তৈরি করব, সবসময় আউটপুটটা ইনভার্ট হয়ে আসবে, and that is good, right? ওকে, আমরা নেক্সট ক্লাসে আরো ডিটেইলস এক্সপ্লেইন করব। এখন তো আমরা অ্যাটেন্ডেন্স নিতে পারলাম না, 34 এসেছে, 33, কে 2 জন আর 3 জন আসে নাই। এনিওয়ে, আমি অ্যাটেন্ডেন্স সবাইকে দিয়ে দিলাম। ওকে, সো 3:30 বেজে গেছে তোমাদের, তাহলে ওই ক্লাসে জয়েন করো। ওকে, উইশ ইউ গুড লাক এন্ড সি ইউ নেক্সট ক্লাস, রাইট? ওকে, ভালো থাকুন ভাই।